Okay, dear student, let's see what is there in this question. Photons of discrete energy are emitted during gamma decay. This is the evidence for what? So, first of all, we have to understand what is happening in these questions. This question is about the nuclear energy level, by the way, so the answer will be B. But what do you mean by this? Actually, there are three radiations that we know. One is alpha, one is beta, another is gamma. So when alpha is emitted, we were interested in finding what is the kinetic energy of the alpha particle. So when we found the kinetic energy of alpha particle, there were couple of energies only which were possible. Like you can say that either it will be this or it will be this. Like these kind of discrete pattern, the energy was distributed. Like all the alpha particles can be categorized into two, like that. Similarly, in the case of gamma also, you were getting the same thing. Like whatever is the gamma radiation, but they could be categorized into two or three categories. Like this will be the frequency, this will be the frequency, or this will be the frequency. But others cannot have any other value. It cannot have a midpoint of F1 and F2. It cannot have something more than F3 or lesser than F3, no, like that. So only particularly F1, F2, and F3 are allowed, but no other frequencies are allowed. So that was a completely surprising thing, like why these things are happening. But in the case of beta, what was happening? A continuous energy spectrum is found. Continuous energy spectrum means that the energy of the beta particle was found to be minimum to be zero, and then there was some max value which was available. So it was found to have a continuous spectrum from zero to max. So many things were learned from this phenomena. Like when alpha was having these two energies, so it was thought that it means that, let us say, this is the energy level for the first nuclei. For the another nuclei, there are a couple of energy levels like this, like this. So there is a possibility that you jump from this to this, and alpha is given out, and then some gamma is coming. So gamma is going like this, like this, like this. So gamma can have couple of values. The alpha can directly jump from the from this energy level to this energy level also, and then it will be going to the ground level. So there were a couple of options available in the case of alpha and in the case of gamma. But when it comes to beta, there was a continuous spectrum that we were getting. Beta is a different case. Let us first consider alpha and gamma. So when alpha and gamma were analyzed, so we came to this conclusion that it means that there will be energy levels inside the nucleus also, in which the protons can make the transition from excited energy level to the lower energy level. It means that from the discrete energy spectrum of the gamma decay or gamma radiation, or from the spectrum of the alpha, we come to this conclusion that the nuclear energy levels should exist. So the answer for this question is B. There is no doubt about it. But there is one more piece of information that I can give you here. And what is that about beta? Now, in the case of beta, it was found that there was a continuous spectrum. But in the case of beta also, further, there will be gamma released. So when the gamma will be released, it will be following the discrete pattern. So gamma is following the discrete pattern every time, but beta in this case is not following the discrete pattern. Now that is a surprising factor here. But why is that? Because when this was happening, we found that there is another particle which is existing, the particle which does not have the mass or which does not even have the charge on it. So there were two particles discovered. One was neutrino, another was antineutrino. So this was the third particle which was coming out when beta plus or beta minus, they were liberated. So neutrino and antineutrino were also participating in those reactions. So this thing that beta is having a continuous spectrum, that was used to describe the existence of another particle, neutrino and antineutrino. Quite elusive. Why? Because it was not having the mass, neither mass nor charge. So they were not aware of this, but later we found it. So this was the essence of the continuous spectrum of energy for beta. So these three things you have to remember, and you will not be having any problem in regards to this. Okay, dear students, all the best. Bye. Please join the YouTube channel.